So this everything shall I call alpha? Okay, what is theta? Temperature difference, this will be. So it is like we used to write theta minus T naught. The average temperature difference. So this will be also like a T minus T naught alpha T minus T naught. Okay, no, this one, I think, yeah. Okay, differentiating this will become minus dt by dt equal to, or this will become dt by dt is equal to alpha T naught minus T naught minus T. This is called like a for cooling of an object. I just brought here. So what is this? The rate at which temperature decreases, no? The rate at which T minus T naught. What is T? Temperature of body. It is directly proportional to the temperature difference between surrounding and the body. So I think, okay, this is a negative sign. Let it be here. Okay, I'll do one thing. This is for cooling of a body. Similarly, the same thing what happen if a body is warming up. If a body is warming up, then the negative sign will not be there. This will become T minus T naught. You need not to do all that one. What is alpha? Alpha is everything that one. 4e sigma a T naught q by ms. That is, this is for warming of a body. Means if temperature of body increases, use this formula. If a temperature of body decreases, use this formula. So there's a one thing is what is suggesting here now. Okay, let me interpret again once again this. This what is this theta? Theta is the temperature difference and T naught will be constant. This T will be varying, no? This T will be varying. So therefore, the same formula, I'll put it one more, still more easier way. This will be final temperature minus initial by time taken equal to T1 plus T2 by 2 minus T naught. Okay, this will become negative sign if I put it initial minus final, then average temperature difference. This is applicable only when the temperature difference is of order few tens, not few hundreds, few thousands also, because the approximation we have done. So this is called like a Newton's law of cooling formula. Alpha depends on what? Material, like already we know. 4e sigma a T naught q by ms. What is this? Initial minus final. What is T? Time taken for the temperature of the body to decrease from T1 to T2. So how you should interpret this one? What is T? Time taken for temperature of body to decrease from T1 to T2. I think very important you have to remember formula. Maximum numericals are related to this. If a body warms up, this formula. Okay, if a body cools on this formula, if a body warms up, this particular formula. Okay, what is the, so like we are not understanding anything. Okay, you brought some formula, something. Okay, let's do one thing. We'll take some numerical itself. on Newton's laws of cooling. Suppose say this is the container, or so like this is a liquid, which is there in calorimeter. Okay, this liquid will have mass, specific heat, emissivity, and it will cool down. Temperature of that, temperature of surrounding, let it be 30 degrees Celsius. The temperature of this, let it be 60 degrees Celsius. Then for 60 to 60 degrees Celsius to become 50 degrees Celsius, if it takes 4 minutes, what time it will take for the temperature to become from 50 to 40 degrees Celsius? And further, for the temperature from 40 degrees Celsius to 30 degrees Celsius, what is the time? He has given only this information. Temperature of surrounding is how much? 30. Okay, this I think 70, I'll write it. It'll be easy for us. 70 will start, 70 to 60. Now very easily you can now compare things. He has given only, we have this much of information. For 70 to 60 degrees, it takes 4 minutes. But the temperature of liquid, no. Temperature of surrounding is how much? T naught. So shall we use directly this particular formula? I'll start from here. Please do make observation, very simple here. So what was the initial temperature? 70, 60. What is the time it will take? 4 minutes is equal to, so this will be 70 plus 60 by 2. What is the temperature of surroundings? 30. So this will be 10 by 4. Here is what alpha, no? If you want to calculate the alpha, or leave it like this. Okay, now time taken for the temperature to become 60 minus 50 by T1, I'll write it, equal to alpha 60 plus 50 by 2 minus 30. Dividing these two will get T1. That's all, no? Dividing these two equations will get T1. Then similarly, time taken for the temperature again, dividing equation 192, then 193 will get T1, T2. Anybody value T1? I need not to bother alpha. I'll have water. Okay, let me check the values. T1. T1 5.6. Yeah, this will be in degrees Celsius. Degrees Celsius. The formula is modified, no? Actually, if you put in Kelvin also, the Kelvin, gets cancelled, no? So in degrees Celsius, you can go for it. T1 5.6 degrees Celsius. T2, okay, I think very clearly in front of you, the information is there. Seconds, or what is this? Minutes? Minutes it will be. Okay, I think you have got very clear information here, no? 70 to 60 will take 4 minutes. Next again for same temperature difference 5.6. For same temp 9.3. So what happened? The liquid initially it will cool down more. No, gradually what happened? The cooling effect decreases. So there's a nice formula. There's a very nice formula. Okay, there's about thing. Okay, let me give another one. Okay, surrounding temperature, let it be 30 degrees Celsius. So similarly, we'll analyze with respect to time. 70 degrees Celsius to 60 degrees Celsius. It will take 4 minutes. In the next 4 minutes, what will be the temperature? And again, the next 4 minutes, what will be the temperature? The same body, that's the same condition. Okay, again, what should be the formula? 70 minus 60 by 4 equal to alpha, average temperature difference. Next, what is the temperature it to take? We don't know. I'll call this is theta1 or T1, anything. This time we know it, 4. This will be 60 plus T1 by 2 minus 30. Similarly, this will be final. T2 we don't know, and this is T1. T1 minus T2, it should be. Okay, T1, T2 are unknown. Dividing equation 1 and 2 will get the T1. That substituting here will get the T2. Anybody value T1, T2? Anybody T1, T2 values? T1 52.5. T2. Just hurry up, T2, T2 value. Anybody value T2? All of you present in class?
Yes, sir.
Then the answer should be given, no? How much of time calculations? 46.87. Thank you, Ma, Meghana. Yeah, 46.875. Okay, see the variation. So these are the types of problems are there. Do at least 1, 2 and come out of that. If different questions are there, okay, carry on that one. Okay, this is about the Newton's laws of cooling. This is one separate independent topic. Tomorrow I'll go for a few more application problems with Newton's laws of cooling and other things, that one, eating that one. Okay, let's go for now the how to calculate the temperature, surface temperature of a sun. So as we know, okay, this is the